In this Blender session, we're going to convert from Cartesian to spherical coordinates. So over on the right here, we're not going to need a very large screen, so hover until you see the little horizontal arrow and scroll over. And we're going to be breaking this, but let's make some room for ourselves. So what we're going to do is drag this over to the left, and we're going to create a custom node, but we'll do the work here first. Okay, so spherical coordinates. Let's calculate r first. So that's the square root of x squared plus y squared plus z squared. Let's go ahead and add a math node. And this is going to be a power node. So we find power here. Let me scroll in so y'all can see that. So I selected power, and we're going to be squaring things. So I'm going to drag x over here. So at this point, that is x squared. So I'm going to duplicate. So that was a Shift D to duplicate. And we're going to square y. And then I will Shift D to duplicate again. And we're going to square z. So we got an x squared, a y squared, and a z squared. Now we need to add them all up. So I'll click on this power node and Shift D to duplicate. That tends to be my preferred way to get another math node rather than keep going up to add and typing math. We're going to add, so we're going to add x squared and y squared. And the reason we add these two first and not y and z is because we need an x squared, y squared for our calculation of theta. And so we'll be borrowing the output here later. But for now, we want to add all of these. So I Shift duplicated my add node, and we're going to bring the first add node to the first input of the second add node, and then we're going to bring over z squared. So at this point, we have x squared plus y squared plus z squared all added up. And what we want to do now is take the square root of that. So I'm going to Shift duplicate, drag the input of the add node, and instead of add, there's already a built-in square root. So that's the one we'll use. So if we did everything right, this group of nodes should be calculating r. So here's something neat we can do. We can select all of those nodes and hit Control-J, just like we were joining them, and it puts a frame around that. So I can click on just a frame, make sure none of the nodes are calculated, and then in the upper right here, the label, we'll call this r, and we can remember that's where our calculation of r is. Okay, theta is next. So we're going to need another math node. And if you remember, this is the arctangent of the square root of x squared plus y squared, and that divided by z. So what we're going to do is change this math node to a square root. We're going to drag the output of this first add node, which was x squared plus y squared, and we're going to drag the output down to this square root. And now we want the inverse tangent. So I'm going to duplicate that node. And instead of the square root, we're going to use the arctan2 function. And then this square root of x squared plus y squared, we're going to drag to the first input of that inverse tan. And the second input is our z coordinate. So I'm going to drag z down here. I can highlight these two nodes, hit Control-J, and then for the label, let me make sure the nodes aren't highlighted. I'll click on just that frame, and I'll call this theta. And because I'm weird, I just like to line those up. And then the last one is the phi calculation. So we're going to add a math node and select also the arctan2 function. And what I'll do is I'll move this closer to the XYZ for a second. And then once I get the connections, I'll drag it over. What we want to do is feed in the X and Y into these inputs, but we're going to do them backwards. So X will go to the second input, and Y is going to go to the first input. And that's it. Now we can drag it down. with just that highlighted, I'll do the Control J, click away from it, then click on the frame, and then call that phi. Now, this is kind of busy and messy, so what we can do is select all of it, and under Node, we'll say Make Group. And what we've done, the screen just changed. We're like, holy smoke, what has happened here? I'm going to click the Tab key. What we're in, we've created a custom node, and we're inside of it right now. So let me hit the Tab key, and that's how you go out of the node. And here's the node, the custom node that we created. It helps us clean up the nodes. So under Label, I'm going to call this Rect to Sphere. Now we can remember what that is doing. That has no outputs or anything yet, and the inputs are not labeled in any meaningful way. But if I click on this and hit the Tab key, now I jump inside, and I can see my inputs here, and my outputs I need to connect to here. If I click on the Group button over here, I can see a list of all the inputs and outputs. And I'm going to click on this first value, call it X, double click on the second one and call it Y, double click on the third one and call it Z. And see how I've named my inputs? And you don't have to follow me here, but if I hit the Tab key to go outside for a second, then my node now has X, Y, and Z labels. So we want to give it the outputs, the R and theta and phi. So I'll click on this and tab back into it. And that's where this group output comes from. So I'm going to drag my R down to the group output, my theta up to that second button that appeared, and my phi to the third one. And then I want to come up and rename those. So the first one was R, the second one was theta, and the last one was phi. And that's all we're doing. So this whole mess of nodes, when I tab out of it, is nice and simple. And we can kind of look if we're correct. What I'll do is I'll duplicate this principled BSDF and just drag that up. This is sort of my temporary thing. And we can look at this and see what things look like. Let's drag the R over to base color. And we can see that it's dark to white, so we definitely see some kind of radial function. Let's make this a little bit bigger. And if I don't see all of my buttons here, if I hold my cursor in this region and scroll my mouse, I can get different options. I think it'll look better if we go to the material shader view instead of the rendered view, because we don't have lighting or anything like that. So, okay, I can believe that that's an R. It may not necessarily be 100% correct. We can't tell at this point, but it doesn't look wrong. And we will know when we create the second node, hook it up, and then see our wave again. Let's just go see what the other ones look like. So theta, we'll drag that to base color instead of R. And theta we know is 0 at the top, and it goes to something large and at the bottom, and we start to seeing it glow. So theta seems correct, and let's look at phi, which is the azimuthal angle. And we definitely see the phi increasing. Remember, it's going from a minus number to a positive number, and Blender just shows all negative numbers as black. But it does look like it's working. To troubleshoot this kind of thing, you'd have to add static values to make sure your numbers are increasing here. But just from what I can tell, everything looks like it is working. So we can delete that principled BSDF, hook our wave back up again, even though we don't have the coordinates hooked in yet. So that's next. So we did our first custom node, which did the coordinate transform for rectangular to spherical. So that is it for this video. I'll see you in the next one.